Good morning. Or night. How are you today? Very quiet, apparently. Okay, so welcome to this talk on Kotlin, ready for production. You're going to have to excuse me. I'm normally a very loud person, which isn't a good feature to have, but I'm loud, but I seem to have lost my voice, so I'm not going to be that loud today. Okay, so what is this talk? It's about Kotlin. How many of you here, let me just stay away from the light. They said to me, don't move from the light because of the camera, but otherwise I won't be able to see. How many of you here actually have played with Kotlin? How many of you have heard of it? This is really good. This is fun because every time I do these talks, more people hear of it. So that's a good thing. So those Google AdWords are working. I'm joking. So anyway, I'm going to give you a brief history of why, the current status, and then we'll just dive into code and just show you code and hopefully convince you or at least show you where the value or the value proposition for Kotlin is. To give you a little bit of background, it started in 2010 by JetBrains, which is a company I work at. And it came about because we needed a language. And we needed a language that was concise, expressive, toolable, interoperable, and overall pragmatic. And we've got the majority of our tools are divided into JVM and .NET platform. The JVM ones are all of the IntelliJ ideas and all of the IntelliJ platform, all of our server-side tools. And then we've got the .NET stuff that is mostly written in C#. All the other stuff is written in Java. And we were looking for a language that could make us a little bit more efficient, a little bit less having to have so much boilerplate code and repetitive things. And so we set out to look for this language. And at the time, the two main candidates were Scala and Ceylon. And Scala had issues, especially in and around tooling and performance. And we know this because we create plugin for Scala. So we provide support for Scala. Just to put it into perspective, if there's about 30 people on the IntelliJ team providing all functionality, there is 6 people just dedicated to the Scala plugin. So it's not the easiest language to tool in the world. We were concerned about the expressiveness or where letting developers loose on Scala would end up. The other option was Ceylon, so we started to work with Ceylon. But unfortunately, at some point, our interests diverged from the Ceylon team. We wanted something that was completely interoperable with what we had. We couldn't just close shop and spend 6 months rewriting everything because we had a lot of code and we have a business to run. So we wanted to interoperate with everything we have with a very smooth experience, and we wanted to gradually introduce this new language. And that's when we decided to, okay, let's just write our own. And our goals have always with Kotlin been to be concise, expressive, toolable, interoperable, and overall pragmatic. Kotlin isn't set out to be a revolution. It's not the next big paradigm shift to programming, right? So if you're an alpha geek into programming, there's much better options there, such as Clojure or Haskell. This is more about seeing what worked, what didn't, inspired by many good languages out there, and delivering on it. It's developed under Apache 2 OSS, and it's basically been on GitHub since day one. The current state of it is we finally released after 6 years. And it took us a while because we wanted to make sure that many of the choices that we made are the right choices. So we wanted to use it enough to be able to make that judgment call. Right now, there's about 20 developers at JetBrains working on the team. But Kotlin isn't our business model. Our business isn't evolved around Kotlin. We continue to sell tools. We use Kotlin now in many of the tools. But There isn't a let's make a company around a language. This, for us, is just a tool. There's about 100 committers on GitHub. It's now close to 10 products where Kotlin is being used inside JetBrains. Some of them are entirely written in Kotlin. Some of them are a combination of Kotlin and Java and some other languages. The new CSharp IDE that we recently announced, all of the front end, so all of the IDE itself is written in Kotlin. The back end is talking to ReSharper on the C# side. If any of you have used JetBrains account, JetProfile, that is entirely now all written in Kotlin. It's currently used by about 14,000 people. Actually, that's got new stats yesterday. It's 17,000 people. And what does used mean? So, and that's only the stats in terms of IntelliJ. So in IntelliJ, we have a Kotlin plugin. We only tell you that there's an update available for Kotlin plugin if you're actively using the plugin. So we know basically more or less roughly how many people are actively using Kotlin. It's by the number of upgrade requests that we get. External companies, I don't like to name drop, but everyone likes name drops, right? And everyone wants to know who apart from JetBrains is using Kotlin. Here are a couple. So Prezi, Expedia, NBC, News Digital. I recently saw American Express has also pushed something to GitHub that's using Kotlin. It's a wrapper around Bitbucket, pushed to GitHub. So there are a bunch of companies. A lot of these are mobile. So Kotlin has become big in mobile because it's compatible with Java 6, it's statically typed, and it works with a very low, small runtime. So it's had this big acceptance in mobile land, but it's not focused around mobile at all, specifically. Where can you actually use it? Absolutely anywhere. In fact, as I said, it is compatible with Java 6, so you can use it on mobile, which is why a lot of companies are now starting to use their applications, their mobile applications using Kotlin. But of course, it can be used anywhere. In fact, you know, Spring Boot recently announced that they've got like first-class generators for Kotlin, so you can now create Spring Boot applications in Kotlin. And because we focus so much on the interoperability, you don't need an entire ecosystem. Anything that's there on Java basically works. Anything that's on the JVM already works, whether it's Spring, whether it's Java 2EE, if you really want. All of these different technologies, libraries, framework, all work. It's similar to Java, C#, JavaScript, Groovy. It's heavily inspired by many of these languages. But this also gives us a benefit in that the ramp-up time is very, very low. So you don't have this paradigm shift. If you know any of these languages, you'll very easily be able to pick up Kotlin. And then there's a few quirks, like not quirks, but idiomatic expressions in Kotlin that you can pick up over time. However, I can guarantee you that I'll show you Kotlin code and everybody will understand. In fact, everything I show you today will understand, minus maybe one or two things that you'll say, what does that do? And again, the fact that it's interoperable allows gradual adoption. That means that I can gradually bring it into my code base, and not necessarily with tests. I can have a class in Kotlin, a class in Java, and have Java call Kotlin, Kotlin call Java. So how can you use it? Command line. Maven, Gradle, Cobalt. Cobalt is an Gradle-inspired build system that is using Kotlin, so it's statically typed. And IntelliJ IDEA, Android Studio. IntelliJ IDEA, you can use both the Ultimate version and the community version. So it's free. Eclipse. We've created a plugin for Eclipse as well. Okay? Hopefully the community will at some point pick that up, but we started it. Okay? So it's not restricting you to a specific environment. Far from it. We're not trying to say you can only use this with IntelliJ IDEA. You can use anything you want. In fact, the command line has got kind of a REPL as well, so you can just use it like that, if that's how you write applications with REPL. Okay, so let's see some code. I'm going to ask if there's any questions, but since even if you raise your hands, I won't be able to see you, I'll just assume there aren't any questions. And we could just go along like that through the whole session, and I'll pretend that you're not even here. I can't see you, literally, which is sad. I like seeing people. Okay, what's this? Can somebody tell me what that is? You're not here. Good. Can I make the fonts a bit bigger? I actually tested this at the back. I'm sorry. Shame on me. 25. Is that better? Awesome. So what is that? It's a Java class. It's a bean, right? It's a custom. It actually says it right here at the top between after class. It says customer in Java. And what that is a lot of things that you're accustomed to. It's boilerplate code that you write over and over and over again. Obviously, nobody writes this, right? We get the IDEs to generate this code for us. So it's not a problem. However, it is a problem as well because it's got a lot of code. Let's see what that would look like in Kotlin. That's what it looks like in Kotlin, okay? So let me do a hipsterish move here and actually do a side-by-side. There you go. So this is basically the code in Kotlin, okay? It's exactly the same thing. var is indicating what I'm doing here is I'm creating a class in Kotlin. Forget that for a moment. I'm creating a class in Kotlin. I'm passing in a primary constructor. In that primary constructor, I'm also defining the actual properties that that class has. So I can have a var, which means it's mutable. I can have a val, which means it's immutable, which means that there is no setter, just a getter. Okay? I have first name, last name, email, etc. On this side, I have the customer in Java, the same thing. But this side, I also have toString, equals, and hash code. And I told you these two were the same. Yes, that's as soon as you add data. As soon as you add data, you get this functionality as well. Okay? So it adds a hash code, it adds a equals, it adds a toString. Now, this is great because it's basically a single line of code. And I hate saying that because I really do sound like Microsoft. But it is a single line of code. And you could say, okay, well, this is no big deal because my IDE generates this code for me. Yes. But now you've got 60 lines of code in your code base, and you have no idea until you look at it to see if there is any custom implementations in the equals, if it's just the default one, if there's any logic, anything. You've seen this code. Here, it's very concise, clear, exactly what it is, right? Nothing earth-shattering, nothing amazing, nothing, oh my God, I've never seen something like this before in my life. No, it's just trying to be pragmatic and precise. Now, I can actually, if I come here and do a main, that gives me a main function. And you can notice that it's top level. So that is public static void main. We'll see functions in a minute. But if I do val customer equals customer in Java, notice how, first of all, there's no new keyword in Kotlin, right? I know that I'm invoking a constructor. But it's different to JavaScript. In JavaScript, you know that you're invoking a constructor if the first letter starts with capital, uppercase. We love our JavaScript, don't we? Customer, first name, email. Notice this. I don't have a get email or a set email. I have an email. In Kotlin, there's properties. There's no fields. I don't need to access the getters and the setters. Kotlin realizes, oh, this is a property. There's a getter and a setter for this. I can access it in a more idiomatic way in Kotlin with just using email. And I can mix and match these in the same code, right? So I can say email, whatever. No semicolons either. So that saves you a lot of characters over 6 years. Now in Java, I could do the same thing. In Java, I could come here, for instance, in a very strange place and say customer in Kotlin equals new, customer in Kotlin, and pass in the parameters. And I think this should be a 1. That should be a something. And IntelliJ just doesn't like, oh no, I'm incompetent. There you go. And then customer in Kotlin, get email. So I get the idiomatic approach in Java versus the idiomatic approach in Kotlin. So mix and match as you want in the same project, in the same folder, in the same namespace, in the same package. Anywhere you want, you can mix and match these things. Okay? Right. So that's great, easy, getting up and running. Now let's move a little bit faster. Functions. What do we have in functions in Kotlin? Let me close this down so you can see it. So again, trying to make it very pragmatic. We have String interpolation, which has nothing to do with functions, but it's a great example to put for you here, and also see how you use a parameter. So we have templating in Kotlin. Notice, again, as I said, top-level functions. So normally, you end up in your code base with helper classes, right? And then you try and figure out where that function is, in which helper class. We've solved that problem in Kotlin. Now you end up with files, and you try and figure out where that function is, in which file. Kind of like JavaScript. So we have default and optional parameters. So you can say, you know, a parameter is string default. What does this provide me? It just saves me on having to have overloads. I can have name parameters and positioning, so I can pass in the second parameter first, the first parameter second. If parameters are single line expressions, I can just return a value. And notice that I don't have type inference here. So I could explicitly say, I do have type inference here. I could explicitly say this is an integer, right? But I don't need to. The compiler figures out that it's returning an integer. I don't need the braces. I can just have a single expression being returned. By default, Kotlin returns unit, which is a little bit different to void. But you can also avoid it. You can omit it. You don't have to actually explicitly put unit. Okay? I can also have multiple arguments in my function. So now I have a function with var arg, and I can have as many functions as I want, as many strings passed in as I want. Let's talk about nulls. How many of you love nulls? I'm going to assume no one raised their hands. So here I have validate customer. If customer is not null, if customer get first is not null, then do this, not null, not null, not null, not null. I'm sure you all know about the null, the billion-dollar mistake. Which in Swiss franc would be like the 100 Swiss franc mistake. So in Kotlin, we don't have nulls. By default, you don't have nulls. So types can't be nullable. So you don't have that problem of checking whether something is null. Just do away with nulls. What you can do is add a question mark and say, now I want to shoot myself in the foot a little bit, and I want to be able to deal with nulls. If you do that, you can see that immediately you get an error here saying that you can only use a safe operator or null, non-null assertion. So what that means is that now I can come here and add the safe operator, which means only call me if it's not null. Okay? So why did we add this? Not because we want nulls in the system, but mainly because of the interoperability. If I am talking to Java, if I'm creating my system from scratch, I'll try not to create nulls. However, if I'm interoping with Java, there's a slight chance that anything I call in Java can potentially return null. If I implement an interface in Java, if I override a class that takes a parameter, that parameter can be null. So that is why we offer this in a sense as well. And of course, for those rare cases that you do want to deal with nulls. So how does that work? Well, initially, when we started with the design of Kotlin, anything that would be consumed from Java would basically be nullable. So that meant that everywhere in your code, you had to end up with something like this. And that seemed like a good idea, but then what happened is that we looked at code bases, and there was question marks everywhere. We said, okay, let's fix this. We wrote an external annotation tool that would then annotate your Java libraries and then say, here, you don't need to use nulls. So then you could do Alt-Enter, and a quick intention would fix that. Now we've basically just said, do as you want. If you are sure that the value coming in from Java is not null, then you don't need to add the question mark here. If you feel it's null, add the question mark. And then do away with nulls. There is also the double hash, the hashbang or the double exclamation, which basically means I know that this is null, but I want to kill myself. So this means even if it's null, force a null reference exception. For those times that you're feeling, wanting to, nostalgic and want to get some null reference exceptions. What else do we have to try and simplify a little bit the code? So here I have an employee that, notice also the classes don't inherit, classes are closed by default. So I don't need, this is the same as putting final in Java. And a lot of people get mad at this, but it's okay. It's about one of the only opinionated things we do. But if you want to inherit from a class, you have to explicitly mark it as open. So here what I'm doing is I'm inheriting from person and saying that an employee has vacation days. The difference between an employee and a contractor is that the contractor doesn't have vacation days. So now I say validate vacations. and I'm passing in a person. And I say if the person is employee, person vacation days is less than 20, take more time off. Now, what is missing there? Anybody can tell me? The casting. The compiler says, I know that this is a vacation. Sorry, I know that this is an employee. You don't have to explicitly now cast it again to an employee. In fact, it highlights it and says to you, smart cast to employee. Okay? Now, if I were to come here and say else if person is contractor, you can see that person won't give me access to vacation days, right? So it's not allowing me to do that. Whereas here, I can do vacation days. And it's just let the compiler be a little bit smarter and avoid us having to do this explicit casting. With conditionals, the last value of a condition, the last line of a value conditional returns an actual result. So I can, again, do this, like say, if input is greater than 100, then do some value, calculate some value here, and then return the last result and assign it to that variable. I don't have to initialize a read-only, a mutable variable, and then alter it based on where I am. The if expression basically returns the value. I'm going to show you something that might throw you off a little bit, but we'll come back to some syntax there, so don't worry. Here is another typical pattern that you have, okay? I have an interface called repository, which takes a generic type of T, restricted to the record, and then I have get by ID and I have get all. Very typical pattern. Here I have a controller, right? And I have the repository being passed in as a dependency. Forget that. I now have customer list and I say get all to string. Where's get all coming from? Get all is coming from repository, okay? Sorry. And in fact, I can do get by ID, and that's coming from repository as well. How is that happening with this line over here? What I'm saying is delegate the functionality of repository, and basically to what the effect of that has is that it's mixing in that functionality into my controller. What does this save me on? On having to follow that typical pattern in dependency injection, which is create a private field and then invoke those dependencies using the private field. Now, the downside of this is, of course, if you have 5 dependencies being passed in, how do you know which one is coming from what? That's where you buy IntelliJ Ultimate, and it will tell you. Jokes aside, you can also get that in IntelliJ Community Edition. But again, jokes aside, if you have 5 dependencies coming in, you're probably doing something wrong to begin with, right? You shouldn't have so many dependencies coming into a class. Just because they're being passed in doesn't mean that your class is inherently loosely coupled, right? Because it's still, I've got 5 things coming in, that class knows way too much. It's coordinating way too many things. So the solution to that is maybe there's a code smell. Now we have also delegation for properties. So for instance, here I have a customer and I have a list of addresses and I want this address to be lazy loaded. So only the first time it's accessed, it needs to compute the value. Forget this syntax here, for now, this thing over here. But basically, we have a bunch of built-in delegation functionality, and you can also create your own delegates to delegate the reading and writing of a property to some function. And here what I'm doing is delegating that to this function, getAddress. You can also instantiate an interface and get the reads and the writes. And here what I'm doing is delegating it to this function. So I can reuse this functionality, for instance, right, and delegate the reading and writing of any property of any class to an actual outside entity. Constructing. So here I have, we've already seen the shorthand for creating constructors and properties. I can just do it on the line. And by the way, classes don't even need to have bodies or anything. I could actually just have a class like that. If it doesn't have anything else, it's fine. There is an init block, which allows me to initialize any code that I need for my class. And also, initially we introduced secondary constructors, then we dropped them and said default parameters will allow you to do anything. Then we realized that there are some cases that aren't the best approach, so we reintroduced secondary constructors. So if you do want a secondary constructor, you can go ahead and create that, according to the base one. Deconstructing. So here, you can see that I have a list of pairs. And in Kotlin, we don't have tuples. Initially, we had tuples, then we dropped it. Now we only have pairs and triples, because anything beyond 3, use a data class. You often lose the semantic meaning of what exactly it is you're trying to represent. And we're trying to make code expressive and concise and facilitate Kotlin to do that. So this, for example, isn't the best idea. I'm going through elements in element, and I say element first, element second. What is first? What is second? I have no idea. What I can do is deconstruct values and say, in elements, I have city and I have country, and give those things semantic meaning. And I can do the same if, for example, I'm returning a pair from a function. So here I have return city and country, and I can say return the pair. And when I'm accessing that, I can deconstruct those values as well and say city, country, return city, country, and then access them directly. Here is the singleton pattern in Kotlin. So in Kotlin, we have classes, as you can see, and you can instantiate those classes. You don't require the new keyword. However, we also have objects. So whereas in JavaScript, you only have objects, and anyone that comes to JavaScript, especially from CSharp and Java background, tries to reinvent classes and hierarchies in JavaScript, in Kotlin, we have both. So it really is appealing to both Java developers and to JavaScript developers, more hipsters. So we have object, and that basically means I've created a single object, a single instance. So you just declare the object, keyword, and the name, and now I can say Jeremy log, a message is sent. That's it. And I can have object implement an interface, have it as an anonymous object implementing something. But if you just want a singleton, just declare it anywhere. And anywhere you reference that, which by the way, notice that we have packages in Kotlin as well. You don't have to necessarily align them with the same structure in Java, by the way. You can have more than one class in a file. You can have 10 functions in a file. The way that you express that, well, the way that IntelliJ shows that to you is that you can see here I have the C icon, which means that this is a class. Here I have a Kotlin file, which means it contains more than one thing. Okay, so we have the singleton, an object as well. Now let's go to what really makes what we're all interested in nowadays, right? Which is higher order functions. Because if you're not doing functional language, functional programming these days, you're not hip and you're definitely not modern, and nobody really takes you seriously. Am I right? Right. Tongue in cheek, right. Are you still awake? Good. Okay, I said I won't shout, I'm sorry. Okay, higher order. So higher order function is a function that takes a function or a function that returns a function. A very nice, clean, declaration of this. I have a function that returns int, takes 2 ints and returns an int. I can invoke that function with any values. Here I have a function which is sum, which can be passed to higher order. I can reference a function by name. So I could do : my sum and just pass in that function. We, of course, have lambdas. Yay! Which is why people like it on Android as well. We have lambdas. Very clean. There's no need to be explicit about the type, etc., and so forth. It's a lot of type inference. So here I say x and y returns x plus y. We have a convention similar to Groovy, whereby if the last parameter of a function is another function, I can drop the brackets. Right? So this and this is exactly the same. Now, what I can also do is this, right? And that starts to look interesting, because given that I have higher order functions, given that I have top level functions, this actually looks like a keyword, does it not? Right? And I could start to do groovy things. Literally groovy things. So for example, if you go to HTML Groovy builders, and I'm sure you've all seen this, right? The type-safe builders in Groovy. Now you have this statically typed. Okay, so HTML is a function, head is a function, title is a function, body is a function. Right? So you can navigate through it, you can create your own DSL. Now, having said that, I don't recommend anyone to create statically typed HTML. It's not the best thing in the world. However, it is good to introduce certain functionality that you repeat over and over again in your code. And I'll show you that in a second. Functional, of course, we also have a standard library that ships, so all of your flat map, filter, sorted by, etc., all of that works. Here I have a data class album, and I have a data class track. Here I have a list of albums. Again, notice the conciseness, no explicit typing required. I have album, then album has a list of tracks. And here I have a bunch of numbers. This is just how I say I have numbers 1 to 30. Very concise. Words, capitals. This is a list of pairs, except instead of me doing pair Zurich and Switzerland, well, it's too long to type. I actually have a built-in function in the standard library, which is to. So I can go to to, navigate to it, and you see that what it returns is a pair, right? So how do I get even numbers? Numbers, filter. How do I get sorted words? Words, sorted. This is all part of the standard library already. You don't need to write this code yourself. How do I get the city of a pair of countries and cities? I say map, get me the first, and then sort it. How do I get albums with tracks less than 3 minutes? I use flat map. Again, all built in. So many of the functions that you would come to expect are built into a standard library. But we try and keep that standard library very, very small. So some things are excluded, such as, for instance, optional and things like that. But there's a library that allows you to do that, which is functionally. It's open source, it's on GitHub. But to give you an idea, if you go, for example, to function composition, now by default, composition doesn't exist in Kotlin, but here is how you can create a compose function, which allows me to compose one function with another and then apply that composition. Okay? As I said, if you want to do things like this, or partial function applications, or currying, which also doesn't come in Kotlin by default, but you could easily create a curry function, and there's already a library called Functionally that does that for you. But going back to what I showed you, let's see the let with apply. So this is where this DSL aspects really shine, right? It allows me to be a little bit more expressive in what I'm doing. So we have a bunch of functions that are built in, such as let, which allows me to, what I'm doing here is I'm creating an instance of file, and then that's a convention we have in Kotlin, similar to Groovy, which if the only parameter to a Lambda expression is if there's only one parameter to a Lambda expression, instead of being explicit about it and calling it X, you can just refer to it as it. So here what I'm doing is I'm saying apply whatever code block I have in here to file and reference it with it. There's also the aspect of using the with function, right, which kind of does the same thing. It takes a receiver and a block of code and applies it. So here I don't even have to prefix it with a it. I have direct access to the values of the file object. There's apply, which takes a function and applies it as well. So these are the little nuggets, tiny little things that you can start to add to your code and truly take advantage of that kind of bunch of things that we've built into Kotlin to allow you to do these things. There's also another example of this where we take it one step further is extension functions. Now, how many of you are familiar with CSharp extension functions? Okay, so in CSharp, you can basically take any class and destroy it. I mean, you could take any class and add new functionality to it. And what you do is you create a static class and then a static method and refer to the parameters, this, etc. This is how you can extend the Java or Kotlin class in Kotlin. I take string and I've just added a new function to it called hello. Anywhere where that package is imported, that value exists. So here I have hello, I've extended welcome, welcome, etc. And what I've done here is now I can do this is me and invoke all of the different extension functions. So hello is now an extension function. I can reference the values of the instance using this keyword. I can, of course, have extension functions that also pass in parameters. So this now opens up more possibilities for me. If I want to do a toJSON, because I'm doing some web programming and I want to be able to easily convert a class to its JSON serialization, I could just create a function called toJSON, because you can create a function on generics as well. Okay, sorry, extension function on generics. Now, one step further with this is what we're doing here. Here I have a class called root handler, which has a request property and a response property. Then I have these classes, response request, which basically has status code, message, content type, just property values. And here I have a higher order function. Now notice there's a slight difference from what we've seen up to now. Here I'm not passing in another function. I am passing in a function extension to root handler. Why would I do that? Because this now allows me to do this. When I invoke route or root, I'm passing in a function, but it's an extension function, which means that I now have access to the class on which I'm extending. So what is that class? It's a root handler. What does that class have? A request and a response property. So this means that technically, I can come here and write, oh yeah, there, I have request, and I have the properties of request. And this is where some power starts to come in, because if I combine this with extension functions, with the conventions that I've shown you, that's how you can do those HTML Groovy builders, right? But as you do HTML Groovy builders, you can do anything you could potentially think of. Okay, what else? So sequences, by default, Kotlin doesn't reinvent its own collections. It uses Java collections. It's compatible with Java collections. We do introduce some interfaces which allow us to create mutable collections or immutable collections. By default, we try and focus on immutability. Right? So list of, all of these are immutable. While you're not enforced to do var versus val, if you do var something, notice that immediately what happens is that by default it underlines it, saying, that doesn't look good. You know, you've got a mutable property, and of course you can come here. What I recommend is if I go to Kotlin and say mutable and do something like, foreground, yellow, and background, green, like that, beautiful. And hopefully it'll look something like that. And you'll stop wanting to do that, right? Like visual pressure to stop you creating mutable values. So we kind of say, you can create mutability. We don't enforce immutability, but we kind of recommend it. And going back to that, going back to the collections, everything is ego loaded. We do have as sequence. And what as sequence does is basically allow you to operate on those collections in a lazy manner. Okay? So now I can basically just go through a sequence of numbers, and as soon as I hit something divisible by 5, I stop. I don't have to process the entire collection. One last thing is algebraic data types. Okay? So here is and I'll show you a typical example where this is useful. So here I have a class which is page result, and this has inner classes, which is kind of inner class. It's got a class that inherits from page result, that has a property called URL, which is called success. There's an error class which returns a value called code and a property called message that also inherits. But I've got this little keyword here which is called sealed. And what this basically means that we're guaranteeing that there's no other instance of any other class that is inheriting page result. What this allows me to do then is, and this is something that we are all challenged with, right? I call some function, and based on whether there's an error or there's a good result, I want to return different values, different properties, etc. So what I could do now is create a page result, a get page that returns a page result. And I say, if the operation is successful, then return success and the URL. Else return error 404 not found, for instance. When I invoke this, I can then do get page, and then in a switch statement say, if the page result is success, then do something with the result. And notice that again, Kotlin says, okay, I'm smart casting this because I know that this is already of a specific type. So it allows me to put to use that concept of algebraic data types, which is, type can be of one type or another type, etc., and use it in a very, in a pragmatic kind of way. Okay? So that's kind of basically some of the highlights in terms of what you could do. I mean, what's the syntax of Kotlin, what it looks like, etc. In addition to that, what are other people doing? So for example, this is Anko. This is a library, an open source project that we've created. How many of you here are Android developers? Right. So if you don't like to do XML markup, this is a statically typed markup. And it allows you to basically define your views using Kotlin, using statically typed Kotlin. This is a library that we've created that's on GitHub. It's called Anko. In addition to that, we've also done something else, which is called Android Extensions, which is available for Android Studio, as well as IntelliJ. And when you're doing Android development, I'm sure you're all familiar with this. Instead, find view, pass in the text as text view casted. So what we do with Android extensions is basically give you statically typed elements that match the name of your view. And you don't have to cast them, and you don't have to refer to them by the string name or the resource name or anything. Just use them as if they were declared in your code. We do this because Kotlin's compiler allows plugin functionality, so we can plug into that, read things while you're doing your development, and provide you with this functionality. Okay. Spring Boot, as I mentioned, right? They're doing the Spring initialization. Now, if you go, you have language, you can select Kotlin. I've got a couple of products that, internal things that I'm working on that are built on Spring, and it works fantastic, no issues. All the annotations, everything works. Absolutely no problem whatsoever. Cobalt, as I said, this is a statically typed statically typed Gradle. So there's a plugin for IntelliJ that Cedric from TestNG is the guy behind this. So this is basically allowing you to do Gradle, but it's heavily inspired by Gradle, but allowing you to use static typing. And there's an IntelliJ plugin as well, which then offers you all of the completion, etc. Spec is a little framework that I put together initially when I was playing around with Kotlin. If you're familiar with things like Jasmine, you have the ability to kind of say, given a calculator on calling sum, then it should return some value. So more kind of like a descriptive DSL in how I execute things. I tell you though, there are limitations with this. So there are some issues, namely the test runner, in that we can't currently support before on and after on, but otherwise it's an interesting project that I started. Now for you, what about your next steps? So if you are interested, hopefully I've enticed you enough to take a further look. If you go to kotlinlang.org, you can download it, the compiler, the plugins, etc. But there's also try.kotlinlang.org. And if you come here, what we're doing here is we've got a series of Kotlin koans that basically teach you how to use the language. So I can say reading a name from a file, and it tells you what you should do. And you can actually kind of do it inside the IDE. So I can say if args, and I should get completion if I had it. There you go. So it's like a mini IDE that basically allows you to go through all of these koans, complete them. You can log in, you can create your account, etc. And you don't even have to download or install Kotlin. If you do want to download and install Kotlin, of course, the koans are also available on GitHub. So you can do it online with, clone the repository and do it in the comfort of your own IDE. There's already 2 books. One of them is Kotlin for Android developers that's available on LeanPub. So if you're doing Android development and you want to learn more about Kotlin, where you can apply Kotlin in Android development, obviously with all of the lambdas, event handlers, all of those things, it cuts down drastically the boilerplate code. There is this book. 2 of my colleagues, Dmitry Yemerov and Svetlana Isakova, are working on Kotlin in action. It's already available on MIA, Early Access Program on Manning. There's, I think, around 8 or 9 chapters already there. So you can pick that up and also learn a little bit more in depth about the language. Community-wise, we have over 2,000 something now, I think like 2,100 or so people registered on Slack. And it's very active, like sometimes too active because you miss a lot of things that are going by. For many years, we had an IRC channel. And there was about 20 people on there. And there was about 2 conversations every 6 months. And we made the decision to, hey, let's try Slack, and it blew up. Like we had like 500 people in the first week, and then it just continued to grow steadily. We were criticized why we moved away from IRC, but hey, nobody was talking. Kotlin on Twitter as well. There is a ampersand Kotlin, so you can follow that for events, etc., etc. And to summarize, basically, what I want to say that this. You'll hopefully see that we've really tried to take a pragmatic approach to things, right? I'm not a big fan of the word pragmatism when it comes at a cost, but here we're not trying to be the next mind-blowing academic language or something, you know, that if you're an alpha geek, if you're interested in different approaches to, you know, radical different approaches, then this is not the language for you. If you have suffered some of the problems that we've suffered, that other people suffered, and just want to leverage your experience in Java or C# or JavaScript and use this and hopefully see that it's more productive, efficient, and concise, this is the language for you. It's got an easy learning curve. And I always refer to Rich Hickey's talk. If you've not seen it, I recommend. It's called Simple Made Easy, where he differentiates something that would be simple in line in reference, of course, to Clojure, and something called easy, which is subjective because we're familiar with. Yes, this is easy, because we're very familiar with other code, other languages that this is based on. Given that it's interoperable fully, it provides a very low risk adoption. So I can gradually introduce Kotlin where I see it provides benefit in my code base. I can mix and match. I don't need to rip everything out and start from scratch. To give you an example, this is an Angular 1 going to Angular 2, right? If you've ever suffered that, or React X going to React X plus 1. And of course, it's enjoyable. Yes, completely subjective, but I picked it up out of casualness, and as a C# developer and someone that likes JavaScript, although I always will criticize it, but I'm not convinced with the dynamic typing of JavaScript, I do find it very enjoyable to write. But that goes the same like with our IDE. When people say to me, like, why would I use why would I use IntelliJ over Eclipse? I say, I can sell you 100 features. It's not going to work. You go, you try it. If you find it a better experience, good for you. Use it. If you don't use it. I'll say exactly the same thing here about Kotlin. Try it. But I promise you, you will enjoy it. And hopefully you've seen, given our commitment to Kotlin, given how much we've invested in it, given that we now have our own products working in Kotlin, written in Kotlin, Kotlin is here to stay. We don't have some major magic thing up our sleeves of saying, oh, we're going to do this business model around Kotlin, and if it fails, we'll dump Kotlin. That was never our plan to begin with, and it's not our plan now. And I picked this up with permission. I saw on Twitter the other day, he said, I researched Kotlin last night and then spending the morning looking at mountains of boilerplate Java and Android Studio, I see why they did it. Pretty much, yes. That's why we did it. So thank you. I think we have about 1 minute for questions. If there are any, happy to respond. If not, just ping me afterwards, and also just before I run away to the airport. Any questions? Yes. We have some problems with Kotlin and data binding in Android Studio, so we can't use right now the use of data binding in Android. You have some problems with Kotlin and Android Studio with data binding. Is it because of some annotations? Yes. There is, I think, one issue open with that right now that we're trying to address, yes. There is, there is probably one or two issues, and you've pointed out to one of them, yeah. I should have told you to ask me that question later, but anyway. Any other questions that are not inflicting harm on me? Yes. Can Kotlin target JavaScript? Yes. We needed to attract the hipsters, so we needed to do this. Jokes aside, yes, it can. In the version 1, we concentrated quite a bit on on JVM, but it can target JavaScript. What we're doing now after 1.0 is trying to refine that experience. So for instance, right now you can share code and interoperate with NPM modules, but we're trying to make it even nicer in terms of the experience. One place where that is really good is, of course, if you're doing server-side validation, client-side validation. Now you can write your classes in Kotlin and have it spit out to JavaScript, have it spit out to Java, and do it on both sides. We're also refining the standard library so that most of the functionality is available in JavaScript and in the JVM. So I think we're done in terms of questions. Sorry. More or less, we've got a public roadmap, but they're telling me I'm out of time. There's performance improvements, JavaScript. There's some scripting stuff. We're improving on the scripting stuff as well. And ping me afterwards. I can tell you a little bit more. Thank you.